All right, guys, so let's take a little bit of time to talk about chemical reactions. Every minute of the day, chemical reactions are taking place, both inside you and around you. Not are all so dramatic as like an explosion and something big you can see. There are ones that are happening right inside of you, right? So think about your body digesting food, or a plant using sunlight to make its food through photosynthesis, right? These are all examples of chemical reactions. So some are big things you see, some are not. In a chemical reaction, one or more substance, known as a reactant, changes into one or more new, okay, so new is a key word there, substance that we call products, okay? So you can sort of think of your reactants as your ingredients and your products what you are creating. Another way to keep these terms straight is to say your reactants react to produce your products. So keeping those words in mind, reactants are working to make your products, your ingredients, and what you're creating. Okay, and again, the key part there that you really need to keep in mind is that in order for these chemical reactions to truly occur, what you end up with has to be a completely new substance. If the product is the same substance that you started with, then it was not a chemical change. A chemical reaction has not occurred. Okay, so let us take a quick look at how we might see these written out. Okay, so you're going to see your reactants are always going to be on the left. And then we use an arrow, okay? So don't use something like an equal sign or anything for a chemical reaction. It's going to be your reactants and then your arrow and then your products. So you might see something like hydrogen peroxide, and then the word we use for the arrow is actually yields. So you can say produces or yields, creates, anything like that. So hydrogen peroxide is actually going to decompose into water and oxygen. So if you've ever used hydrogen peroxide on like a cut or anything like that, sometimes you see that like bubbly sensation. That is the oxygen gas being given off. So that's using like in a chemical equation in words, but you can also sometimes see them right using symbols. Okay, and so these are some things that we are going to be looking at this year, is understanding how those processes work. But again, the hydrogen peroxide, that is our reactant, and then the water and the oxygen, those are our products. So those little bubbles that you see when you use the hydrogen peroxide on your injury, the oxygen that is being given off, that is what we call evidence of a chemical reaction. We have 6 different things that we are looking for to show us that a chemical reaction has occurred. You don't need all 6, okay? Simply, sometimes 1 is sufficient to show you that a chemical reaction has occurred. But there are 6 things that scientists are going to look at to help them understand that a chemical reaction has occurred. So the first, we say a transfer of energy. So in science, energy is dealing with heat. Okay, and so when we say a transfer of energy, we're talking, was heat absorbed or was heat maybe given off? So think about cooking, right? In cooking, heat is being absorbed to cook your food. In terms of heat being given off, right? So there you might see something like light or fire. Those are definitely showing you that heat is being given off by that chemical reaction. Okay, so transfer of energy, that's one. Our next one is a change in color. So those are pretty obvious when you see them. So if you think about like a white piece of white bread that molds, that mold is now usually like a blackish greenish color. That color is evidence that a chemical reaction. Going along with our awesome example of mold, mold also usually smells. Okay, and so the change in odor, that could be our third example of a chemical reaction has occurred. Another example is the production of gas. So again, thinking back to that hydrogen peroxide example, when you use it on a wound and it bubbles off, you see that oxygen gas being given off. Okay, so creation of a gas, the production of a gas, that's going to be number 4. Number 5 is the formation of a precipitate. So a precipitate is a word that we use when a solid sort of settles out or comes out from a liquid mixture. So an example of this would be like a soap scum ring in your bathtub, right? We got to clean those every now and again. So the water and the soap, those are not solids, but over time that reaction is creating that sort of soap scum ring in your bathtub. Okay, and so that solid, that precipitate formed, is telling us that a reaction has occurred. So that's number 5. And then number 6 tends to be like the most obvious, and it's something that cannot be reversed. So don't. If you think back to the graham cracker in the video, right? So the graham cracker was crumbled and it couldn't be reversed. We couldn't put it back into a graham cracker, but it was still a graham cracker, right? It was still the same substance. So that's not a chemical change. But if it has turned into something totally new, and you can look at that and you say, well, I certainly can't turn that back into what substance it was originally, then that's what we say not easily reversed. Okay, so quick recap of what you're looking for: a transfer of energy, a change in color, a change in odor, gas being given off, a precipitate being given off, and then number 6, not easily reversed. So again, the very, very key thing to keep in mind when we're talking about these chemical reactions is that you are creating something new, right? So a iron nail turning into rust, bread becoming mold, silver becoming tarnish, right? That like weird, shiny, gross layer that forms on silver, an explosion of a gummy bear, perhaps. Okay, so these things, we are creating a new substance as a product. And so that is what you are looking for in a chemical reaction.